So, hello everyone, and welcome to the weekly session that we conduct, Ask AuxEn Anything. And as all of you know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to any RCC steel design concept or construction site related issues or any particular project that they are doing. So, this is the 57th such session that we are conducting. And let us begin by taking the queries that have been asked for today's session. So, first, we will take the queries from the Google form, email, and then we will take queries that have been put in the live comments. So, let us start. And the first question has been asked by Mr. Raghu. So, he has put a series of queries. Let me just share my screen and take them up. What should I do? So Mr. Raghu is from Bangalore and he is a working professional and he is a regular participant in the courses as well as in asking asking queries in the weekly episodes. So he has shared some images on the email as well. Let me just take it. So first query is asking, and for that he has put this supporting image. The isolated footings are located very close to each other, and at some locations they are overlapping. These footings have already been cast. These footings have already been cast, and soil has been filled up to plinth level, but flooring has not been done. Has not been yet done. How can we avoid the overlapping influence zones in this condition? So, what do you mean by overlapping influence zones? You mean the pressure bulb theory? So, what you need to do in such cases is, I mean, technically, you should be checking, for example, if you have a footing and just a minute. Is I hope the screen is visible to all of you. Yeah. No. Arre, I have not shared my screen yet. Sorry about that. Yeah, so these were his queries by Mr. Raghu, and I have just started with this first query. So he has shared this supporting image. The isolated footings are located very close to each other, and at some locations, they are overlapping. There's some problem. Just give me a minute. The screen seems to have stuck up. Not sure what's happening. Yeah, I think now it's fine. So are located very close to each other, and at some locations they're overlapping. So he has marked these overlapping zones. The foot, but flooring has not been cast. The footings have already been cast. The backfilling has been done. Flooring has not been cast. How can we avoid the overlapping influence zones? So I'm not sure what do you mean by over avoid, because they're already overlapping. If you see, I mean, the footings are cast very close to each other. So what has been done has already been done in your case. But when it comes to overlap, generally we check by the pressure bulb equation or the pressure bulb theory, where let's say this is my ground level and you had cast your footing like this, So this footing will have a certain uh, pressure bulb, and this pressure bulb is, I think, called as the Bosenisk's pressure bulb theory. And if you have a footing very close by other footing, okay, it will have its own pressure bulb. Now the intensity of the pressure bulb, I mean, this is not a very correct picture that I have drawn. The pressure bulb intensity is more just below the column. Obviously, it depends on the type of footing also, but it is more below the column, and it gradually decreases the intensity or the values of this pressure. It gradually decreases as you move away from the column center. Okay, so in such cases what you need to do is you may need to plot the pressure bulb depending on, and the I think we were taught when we were in third or fourth year. So the screen has just stuck up. I don't know what's happening. Yeah, I was drawing this image. So I was drawing these pressure bulbs. These are called as the Bosenisk's pressure bulb. So below a footing you get such pressure bulbs, and the intensity, as I was telling you, is the maximum just below the column, and as you move away towards the edges, the intensity also decreases. So let's say here is the interference zone where the two pressure bulbs are intersecting. So over here you need to see the total intensity, and if this total intensity exceeds the SBC of soil, but remember at this level, SBC of soil at this particular level, naturally what will happen, that at this level you will have a greater SBC value, isn't it? Because whatever footing you have cast has been cast by doing the SBC at the footing base, but the pressure bulb sort of intersect each other at a lower depth or at a greater depth. So at this location, whatever is the SBC, if the combined pressure bulb intensity goes beyond that SBC, then it's a problem. Otherwise, even if these footings are very close to each other, it's not a problem technically. Okay, I hope this answers your query. So overlapping, I don't see overlapping as such. I can still see some gaps. And let's suppose if it is overlapping, that means if you want to avoid, from the constructional point of view, if you want to avoid overlaps, maybe you can slightly, for example, right now this was a square and this was a square, and they were sort of overlapping into each other. Maybe you can slightly change their shapes to make it slightly, let's say, rectangular, and by making them rectangular you may avoid that overlap, because now you decrease this dimension and increase the other dimension to avoid the overlap. So avoiding overlap can be done obviously before the footings are cast. Now if the footings have already been cast, I don't know what you want to do. Now you cannot avoid anything. Whatever has happened has already happened. So, suitable remedial measures, I would say, just check this pressure bulb, with respect to this pressure bulb theory, what's happening, and check it with respect to the bearing capacity at this particular level where the pressure bulbs are intersecting. And if, let's suppose that you are getting a case where your combined pressure bulbs are going beyond the SBC at this level, then you don't have much of an option left now. Understood? Because your footings are already cast. So maybe then you might look at maybe slightly managing the footing size by increasing its plan area. But then the footings are so close to each other that I don't know if you will be able to increase the sizes any further. So not much option you have right now in this case, because the footings have already been cast and they have become so close to each other. Yeah. So this was his first query. Then he has put another query. There is an 11 meter by 11 meter grid with slab, and he has posted an image for that. I'll just show you the image. So this is the supporting image he has provided. 11 meter by 11 meter grid, with size 450 by 750 and no column. So there is this beam and this beam. Both are 450 by 750 and no column is provided at the center. Although the beam is passing in E-tabs, is this structural arrangement practically acceptable? Yeah, why not? This is acceptable as long as all your design checks are passing, your deflection limits are well within control. Remember that it has to be whatever you are checking in E-tabs, without, if you are doing just your uh, normal deflection calculation for dead plus live, it is the short term elastic deflection, but that deflection value will be much higher if you go for the uh, long term crack deflection. Okay, so let's suppose you have not run any crack section analysis for finding out the deflections. Whatever deflection you are getting over here right now, remember that the final long term deflection with the effect of creep and shrinkage will almost be 1.5 to 2 times greater than the current deflection value that you are getting. Okay, so remember that point. Accordingly, design your beam depths and slab thickness. So whatever deflection you are getting, if it is the short term elastic deflection that we usually get, if you have not run any crack section analysis, then remember that your actual deflection for creep plus shrinkage will be almost 1.5 to 2 times, sometimes as high as 3 times the deflection that you are getting by normal dead load live load. So take that deflection value and ensure that it is less than the codal provisions, let's say L by 350 or L by what? L by 350 that is given in the code. Understood? Yeah. Otherwise, if all other checks are passing, it should be good enough. If all other checks, flexure check, shear check, and this deflection criteria that I just mentioned, if all these are passing, this is an acceptable structural system. Mr. Raghu is adding over here that we are reviewing the footings. We need to give the recommendations for the same. Yes, so recommendations, you check this pressure bulb thing. If the pressure bulb thing is getting satisfied, then no need to do anything. Go ahead as it is. Otherwise, you don't have much options left right now. If let's say your pressure bulb check is not passing, now already you don't have any area that is available to you, so maybe then you may have to go for a raft, go for a big raft, put above the existing footing. So you may have to go for such raft thing, put above the existing footing, and then you will have to do all sorts of rebarring and all those things. Of course, for that you will have to dig up the backfilling that you have already done. So all those things you will need to do. Other than that, I cannot see much possibilities. If you have the option of piling, maybe, but then it is too complicated to do piling because your footings are already cast. So I think go for this type of a raft if your pressure bulbs are overlapping. Otherwise, no need to do anything. Okay. His next question is, he has shared one more image, which I will just put it. So he's asking, this is the image he has put in the RCC structure shown. Uh, In the RCC structure shown, this particular structure is designed to support a 35-ton transformer. The 2-meter cantilever beams. I'm not sure which is 2 meter. I'm supposing this dimension is 2 meter and are showing a deflection of about 10 mm. Now I'm also not sure where he has put the transformer. I'm supposing the transformer has to be put over here. What is this thing doing? I'm not sure. Maybe the transformer is over here. Yeah, it seems to be at the upper level. Maybe this was the plinth he had made. I'm not quite sure right now from this image. And I am supposing that this span is 2 meters. 35 tons is a significantly large transformer weight. So his question is, uh, for this 2-meter cantilever beam, he is getting a deflection of about 10 mm tip deflection. Now for 2 meters, 10 mm is a lot. Yeah, 2 meters, 10 mm deflection is significant. That too, I am again supposing that you have just taken the deflection for dead plus live and you are getting the short term elastic deflection where you have not run any crack section analysis. So your final deflection long term with the effects of creep and shrinkage in such cases where this transformer load is always going to be there, it will be quite high, again almost 2 to 3 times the final deflection value will reach almost 2 to 3 times what you are getting right now. I'm supposing this is just the short term elastic deflection that you have checked. Okay. So this deflection of 10 mm is significantly high. What measures can be adopted to reduce this deflection? So the measures adopted, maybe add a column. I'm not sure why this is a cantilever, why you are not able to add a column. So one of the measures could be to add a column, or I don't know, try to have a backspan if possible. This is right now a cantilever without any backspan, so try to have a backspan if possible, uh, or try to go for some sort of knee bracing arrangement. Of course, if you add a knee bracing, your columns have to be made stronger because then that knee bracing will induce moments in the column. So go for that. Make your beams uh, deflection for earthquake load case. He is saying no. What is the deflection for dead plus live? Because you are already having a 35-ton load, which is not a small load, uh, if you see so, isn't it? So if you in EQ case you are getting this deflection, I'm sure in dead load plus live load also you're getting significant deflections. In dead plus live also you're getting significant restrictions. So significant deflections. Another option could be, let's say you try to have this, try to take the columns above if you can. Try to take the columns above like this, and maybe from the top you may think of putting some tie element like this. This can be another option that comes to my mind. Uh, yeah, so these are the options that are coming to my mind right now. But this system overall does not look a very good system, in my opinion, for a significantly high weight of transformer that you want to put. Also, he is asking, can we adopt span upon 180 as the allowable deflection limit? No, there is no basis for this. I'm not sure from where you are getting this span upon 180. There is no basis for this in the Indian standard. Dead plus live he is saying is 7 mm. So 7 mm, and assume that this is the short term elastic. So your long term deflection with the effect of creep and shrinkage, and because this transformer load is always going to be there, you take it almost 2.5 to 3 times as high the deflection value will become. Now for 2 meters, L upon 350, let's say L upon 250 also, if I take, because I'm supposing there are no partition walls that are going to be put in this. So even if I take L upon 250, I'm looking at 8 mm permissible. And what I am getting final long term deflection would be in the tune of 20, 22 mm, just doing 2.5 to 3 times. So right now your deflection is not passing. Deflection check not getting satisfied. Okay. So try to take these steps and see if it improves the behavior. Then his next question is, in the seismic design of retaining walls, should we consider the dynamic earth pressure for stability checks or only the dynamic increment? Dynamic increment means? I'm not sure what dynamic increment means. But if you want to, I mean, of course, you should check the dynamic pressures for stability. Otherwise, what is the point? If under the effect of, uh, let's say, an earthquake event, if your retaining wall is unstable and it collapses, it falls down, what is the point of that design? So, of course, it has to be checked for stability also. In stability, I'm not sure at this point that when you are doing the stability check, are you allowed to, let's say, go for some reduced factors or not? That I'm not sure right now. For example, we have some 1.4 factor for overturning. Am I correct? I'm not slightly confused. Is the stability factor 1.4 for overturning and 1.2 for sliding? So, under the effect of earthquake loads, do these factors remain the same or can we reduce these factors slightly? This point I'm not sure about right now. Maybe you need to go to the IS 1893, which part deals with seismic on retaining structures. I think part 3 or, yeah, part 3, I think, or part 5. Old IS 1893 2016. So you check that whether these factors can be modified when checking for EQ effects, but you have to check for stability, obviously. Okay. Then his next last question is, please briefly explain how wheel loads are applied as live loads on box culvert as per IRC provision. So see, first of all, it depends how your traffic is going to pass through box culvert. Suppose, let's say you have a single cell box culvert and then your traffic direction is like this. Okay. So then, first of all, you need to go to IRC 6 and check which particular loading type is applicable. Uh, okay, dynamic increment Mr. Raghu is adding is given in IS 1893 Part 3 code. Okay, I'm not sure about that. I have not read it. But stability also needs to be checked, obviously. So check for stability also. So if your traffic motion is like this, okay, and you have a certain dimension of your box girder, whatever those dimensions are, the first thing you need to check as per IRC 6 is which class loading you have to apply. Class A, Class B, Class what? There is a 70R loading, Class 70, I think. So first of all, decide the load that you have to apply. Now, generally, if your loads are passing in this direction, and for small culverts, the distances between the wheel loads are such, the distances between the wheels are such that at one instant only one wheel can be there on the box culvert, isn't it? Although you may be doing a class A or class B or whatever class of load you are taking, the distance between the axles as per the IRC 6 is such that at any instant only one axle will be over the box culvert. So in such cases, even applying the loads as point load is good enough. Yeah. Now, since the box culvert, uh, now you may do it, since the box culvert is framed like this, most of the times it will be spanning along the short span only. Along the long span, the movements won't be much. So you may take a representative, let's say 1 meter. If you want to avoid yourself in making the entire model, you may just take a one small width model, okay, representative, let's say 1 meter model, and just apply the loads. Now in such cases you may apply it as a point load. If you want to make a full 3D model, uh, So if you have decided to make a full 3D model like this, okay, and traffic direction is in this direction as I've shown, then you need to maybe consider two loads, 2 point loads, and then see what's happening. Now if you have a multi-cell box culvert where the width has become such that more than one wheel, or let's say more than one axle can be there, then maybe you can apply as a group of 4 point loads like this, and check for the possibility that next axle can it be there or it will lie outside. And then for such a possibility, you may have to manually work out what is the position that gives you the worst effect. Okay, so I think such a thing can be done. First try to study what's happening and then take this decision. Now, if your traffic direction, although it's quite rare, but there might be a situation where your traffic direction is moving along the length of box culvert. Although it's very rare that this thing will happen, let's say, but your traffic direction is moving in in this direction. Then again, you so at least then again you may see that how many axles can be there on the length, and accordingly you can take the point loads. Okay. Yeah. So this was engineer Raghu with his queries. Now we move on to the next set of queries. So they have been asked by who is asking it? Engineer Rohit Dogra. He is from Himachal Pradesh. He is a working professional, and he has put this query. I hope the query is visible. And he has put one supporting image also. So he is doing this kind of an ETABS model, and these small legs are failing in design. Some in vertical reinforcement and some in shear. So these are small nibs. So for example, this is the wall, this is the nib that is failing. Then this is the wall, there is this nib that is failing. This seems to be failing according to him. This is failing. This is failing. These nibs are failing. I'm not sure how could you find out in this continue. I mean, this is the complete wall that you have given. In this case, how you could find out that this corner is failing? I'm not sure, because ETABS will not give you whether the corner is failing or not. Of course, in this case, yes, it's possible because you may have given a different peer label to these small. These are called as nibs usually. So in your wall, if you take this kind of a projection for supporting beam elements, it is called as a nib. So as of now, I'm not sure how you could figure out that these corners are also failing, because ETABS will not give you any separate result for these if you have assigned a complete peer label. Second observation is why there are so many walls in your model. I'm not sure why there are so many walls. Uh, just too many walls, it seems. Now, some he is saying some nibs are failing in shear, some in vertical reinforcement. What is the reason and how to pass it? See, you need to study, first of all, the failure needs to be studied, whether you are getting any plant torsion, and is it because of the plant torsion that there is a failure. Okay, Mr. Rohit is adding spandrel is connecting. Okay, so you're saying this is a spandrel beam that you have provided. Okay, so that means what he's saying is that he has a wall in elevation like this, and at certain locations he had some openings, and this was, let's say, a spandrel, and then he could see that there was a failure in these uh, pier legs. Is that correct? And here also, of course, because this he is, maybe he has assigned this as the spandrel, and this was his pier. So first of all, check for which, yeah, okay. So first of all, check for which load case they, I mean, on which, under which effect they are failing. First of all, check that if this is the case of spandrel and these pier legs are failing, okay, they might be failing under the effects of flexure. So you need to see and try to put more reinforcement if possible, or try to increase the thickness of these pier labels if they are failing under the effects of flexure. For shear you cannot do much, because for shear, if it is failing in shear, the only option possible for you is to revise the concrete cross section sizes. So in such cases you may have to either go for increased wall thicknesses, or you may want to uh, go for a double shaped arrangement where you locally thicken this corners and provide a smaller wall depth in the central portion. Also see why, if there are planned torsion effects because you have provided so many walls, and overall the, I mean, I don't see why the reason for providing so many walls in your floor plan. Just check if so many walls are required. If at some locations you can reduce the walls, I think that would be even better. Okay, so try that. And then over here, if these nibs are failing where the beam is connected, if these nibs are failing where the beam is connected, just see these fail generally due to the load transfer that happens from these beams to these nibs. So check what type of system you are trying to achieve, let's say in the x direction and in the y direction. Now because you have so many walls, probably you want to just go with a RCC structural wall system, and you're not relying on the beam framing to, let's say, transfer much of the loads. So in such cases, check if moment releases are an option for you, and of course that has to be done, or that has to be ensured that proper site detailing is done on site also. So check if moment releases at the beam ends is an option, because anyway you have so many walls that there is a RCC structural wall system in both directions. So check that, maybe that resolves your corner nib problem. Okay, yes. So try these things out and then let's see what happens. The next question is from engineer Rupesh Khandekar. He is from Pune and he is a working professional. He is asking, in ETABS design, in ETABS software, can we, so what he is saying is quite important question. So let's say this is my ETABS model in elevation, and then whatever, this was my model. And generally what we do is that at the column base, let's say we have provided some fixed support. Okay, so we provide some fixed support, and then we take this base to safe, and in safe we will uh, have our substructure designed, and in safe we will apply some subgrade modulus. So to the footings we will apply some subgrade modulus over there. So his question is that if you are assigning subgrade modulus in safe, then in ETABS you had assigned fixed supports and you had done the analysis, and when you took it to safe, you suddenly applied subgrade modulus or spring stiffness. So will it not affect your analysis results? So very good point he has raised. So what we do in ETABS, if we are providing a fixed support like this and taking it to safe and then designing or then putting the subgrade modulus and then analyzing, or then doing the design in safe, assuming spring supports, then what we are doing in ETABS is not very accurate, not accurate. So that means you should be assigning the spring stiffness in the ETABS itself, because the spring supports may affect your analysis results in your vertical members mainly. Understood? Especially for the column effective length change. Okay. And that may affect the analysis results, because the column stiffness also changes basically. So when you assume fixed support and do the analysis, the results will be different from what you would get when you assume stiffness below the column. So obviously, it's not a very accurate way of doing it. So your absolutely correct way should be to assign the spring stiffness itself in the ETABS model below your column. But then what used to happen was that in the earlier versions of ETABS, you did not have the option of providing spring stiffness, spring supports, because those capabilities were there in safe only. In ETABS, you did not have the option of providing area springs. That option came in later versions. So therefore, the usual workflow still has been that you provide spring supports, analyze the system in ETABS, then take it to safe, then assign spring supports, and then do the substructure design. But yes, I totally agree with your query, and your point is very valid, that if you want perfection or if you want accuracy in your analysis, then you should do everything in ETABS itself, which includes the modeling of superstructure elements as well as putting the spring supports. The results, it will impact the results slightly, and those results mainly will be the results will mainly affect the columns. Vertical members are the ones which will be affected in the sense, if you assign fixed support and analyze it, versus if you assign spring supports and analyze it. So yes, there are differences that you would get, but then in most usual structures, those differences in the results are not very high. And because your software earlier did not have that capability, so we sort of uh, just continue doing in the manner which we do, that is assigning the fixed supports in the column and moving ahead. But yes, for better results, you should assign spring supports in the ETABS model itself. That means you should model the substructure also, and then assign subgrade modulus and then do the analysis. Okay. So this was his query. The next question is from engineer Mohammad Naushad Alam. He is a working professional from Patna. Raft fold question emailed. So he has sent one query on email. Let us look at his query. Are you able to see this? Yeah. Let me just take the query that he has put. The detailing of 500 fold is not provided. The detail of 500 fold is not provided. He has put this image, and then he has put couple of photographs. What is this query? The detail of 500 fold is not provided. The detail of other similar sections are attached. Plan view is attached. Site progress photo is attached. Kindly advise the proper detailing arrangement in compliance with American code provisions so that I can defend myself to suggest that this site progress is not proper, in which top bar from raft is going to top of wall. So they have made a 500 fold over here. Here it says 500 thick raft and minus 2.05 is top of footing, and here it says 350 thick raft and minus 1.15 is the thickness top of footing. So what is the difference between two minus this and this? How much is the difference? Just see 2050 and 1150. What is the difference, please? 2050, 900 So if I were to cut a section like this, if I were to cut a section like this AA, how it should look like? So this is 2050, and then on this side is 1150. This is 2050. Now this raft is 500 thick. This raft is 500 thick, and this raft over here is 350 thick. Okay, so this is 500, this is 350. Just find out the difference between this and this level, please. So 1150 plus 350 minus 2050. So this difference is 550. And then they have, so this line will represent this, and then they have made a fold. So the dotted line is this line that you cannot see in the picture. So I think this type of an arrangement has been made, what I can understand from the plan view that has been provided. Do you understand what we have drawn? Hello. So this dotted line is this line, this representation. Okay. Wait a minute, I'm just thinking. Actually, they should have not drawn it like this. This line should have, actually speaking, because we generally cut this section looking downwards, there's a small mistake in this drawing. Generally, we cut a section like this, looking downwards. So what they should have done, if you were to ask me, that this line should have been made dotted, this orange line should have been made dotted, which would have represented this, and this brown line should have been made solid. Yeah, this should have been made solid, which would have represented this line, and this orange line over here should have been made dotted. Anyway, so this is the arrangement that has been provided. It seems Z Go Green is saying there is a 900 difference. Yeah, that's what we have drawn. So now what is your query? Okay, so this is the section we are looking at. uh, Proper detailing arrangement. So see, proper detailing arrangement in such cases, what you could do is that in such cases, this bottom bar, this let's talk about this top bar. So let this top bar, you may leave it over here. Okay, you cannot, because generally we are assuming that in the design they must have assume the designer, that is, at this fold, because the fold is almost what 900 difference, so they must have assumed a edge release over here. So edge release means they are not relying on the continuity effect at this location, because you cannot have continuity with a 900 difference. So what we can do therefore is, top bar you can leave it here. Okay, the bottom bar in this case, some people leave it here, some people may take it like this. That depends, it varies from the detailing to detailing. Again, the top bar over here, you may just leave it here as it is, or you, if you want to take it up like this, that can be done, but it will not solve any purpose as such. Okay, so it is better if you can just leave it as it is over here. So assuming a edge release, you just leave the bars as it is. If you want, actually, let me just see. If I don't want to go for edge release, and if someone argues that if I have the development length possible, just try it out if this development length can be provided or not. So for that, you need to see how much is this length required, because you took the name of American code. So you need to check, this is called as LDH, this is called as L extension. This L extension has to be at least 12 times bar dia, and check for this LDH calculation. If you are getting sufficient LDH, then in fact you can go ahead with no edge release assumption also, and assume a continuity effect over here. So the same check needs to be done for this bar also, this brown bar. If you are able to get sufficient LDH, then you can assume that moment continuity will be provided. Okay, bottom bars you can just leave it as it is without providing any LD. So you can just leave the bottom bars. If required, you can also provide a beam like arrangement in this fold with some stirrups, just to tie up everything and reduce the requirement for this development length. Okay, so these can be the steps you may follow. Understood? Okay. There is a similar section for tank sump. Yeah, so generally in tank sumps, tank sump, the same thing happens, that there would be a sump like this, and there are raft folds. Now these are small folds, so generally we assume that this is a release, and we may just, sometimes we just leave the bar as it is like this, and leave the top bars like this. So here we may assume a edge release, because the plan size of sump is very small, it's only 400 by 400. So it does not matter if we don't provide any edge release, I mean if we assume edge release and just leave the bar as it is. But over here the fold is happening over a longer length. That's why we are just trying to see if development length can be provided. In my opinion, such type of sections are not good. Making a corner like this, what I would have suggested is to not take a sharp turn like this, and instead go for a 45-degree type of thing over here. So that means uh, the top section remains like this. In case of bottom section, I provide something of this sort. So instead of a sharp 90-degree turn, I just gradually make a 45-degree turn and provide this type of section at raft fold. Okay, so this was engineer Naushad Alam from Patna. Next question we have is from Harpreet. He's from Gurgaon. I am Harpreet, past MTech structures, and working as a faculty. Now want to transition to full-time structural design. Is it possible for me to make this transition? And what are the chances and timeline? need your guidance on which domain in structure should I go. No, so it's good that you have already done MTech, so that means you have the basic knowledge available with you. And since you, okay, hello, yes, Harpreet. So, and since you are also working as a faculty, I'm sure you already have a good command on the subjects, on the basic subjects. Okay, so making transition for you as a full-time structural design will be quite easy. Okay, because you are already masters in structures and as well as because you are already involved as a faculty member, you have a good command on the subjects also. So the making the transition for you will be very easy. In fact, I know many professors, many teachers, many faculty members who have who were working as a faculty person for a long time, and then they made the switch to structural design and are doing very well. So of course that shift is, you can do, you can make the switch, and for you it will be very easy because you have the basics in place. So, how to approach it? I would suggest maybe one way could be to just stop working as a faculty. I mean, just resign from your job and just join somewhere in a design office. But then it might not be a good option to just leave the college without any other stable income source. So maybe first thing you may do is to start working part time somewhere, maybe after your college or before your college time. Just get associated with some design office in your city and start working there as a part time to begin with, and then slowly as you gain confidence, maybe then you can make that shift and maybe join a design office full time. That can be one way. If you want to go all in, then you just leave your job as a faculty member and join somewhere full time in some of the design offices, but at least give yourselves around 1 to 2 years working in some design office, and then you will get to learn, I mean, then you will start understanding what things are happening, what is happening. The theoretical concepts and the core knowledge you already have. So now it's only the application part that you will learn in these design offices. So 1 or 2 years is good enough time for you to sort of understand what's happening and get a grip of things. Which domain in structures, I don't know. I mean, start with RCC design, maybe start with RCC buildings, because that is the most common domain, or that is the most common area in which structural designers work. So maybe start from the thing which is the most common, and then as your choice or as your interest, you may move to steel structures or industrial structures or whatever. RCC steel or BI. See, BIM is building information modeling. It is part of any project that you want to do. Okay, so BIM is not different from, BIM is part of every project, that may be RCC, that may be steel. But don't do BIM right now. You are masters in structures. You start from RCC buildings. Maybe learn steel design. Work somewhere where steel designs are also being done. So start with the simplest and then uh, move ahead. Okay. All right. So this was Harpreet with his query. So these were the questions that were there on the Google form. Now let us see if there are any queries in the live comments. So Mr. Islauddin is asking, banquet hall of 24-meter width and length of 60 meters with a base spacing of 6 meters. It is to be made with hip roof slopes. Can you please draw a tentative sketch of structural arrangement? And what are the points which are to be taken care of? How to apply the wind load on it? No, but do you not have any sketch? I mean, in which direction you want a hip roof? That question is not clear. What he's saying is this is 60 meters, this is 24 meters, and the columns are 6 meters. No, so in which direction you want the hip roof to be, and what is the shape of the hip roof first of all? That is not quite clear from your question. With hip roof slash four slopes. Oh, I don't know whether he is saying like this. This is he saying like this? This has four slopes. Maybe let's assume he's saying like this. So first of all, you need to have some elements in this direction. So the main beams should go along this direction first of all. Okay. Try to have this hip arrangement. I mean, this corner should. This sketch is not very good, but this corner wherever you are having, you should have a column in front of it like this. Okay. So this beam rests on this. Maybe you have to go for this beam also. Just hold on, I'll be back. Yeah, so then these corners have to be taken care of. And as I was telling you, your main beams go in this direction. At these corners, it's slightly tricky. So your framing arrangement has to be has to include a column at this point in just at this tri-slope junction, and then one of your beam arrangements may go in this direction. So it will be better if you have any sketch and the exact hip roof arrangement that is required. That will be easier. Okay, right. Then the next question is in live comments is from Bhatt 3090. If the long span 11 meters in seismic zone 5, only long term deflection check. I think he was asking for this. Yeah, I think his question was related to this. If the long span is in seismic zone 5, is only long term deflection check. I think he's asking is only dead load plus live load long term deflection check sufficient? Yeah, it is sufficient. What else do you require? You may check for vertical earthquake, but a vertical earthquake, because the spans are so high, you will have good amount of dead load, live load, gravity loads. So yeah, I mean, just vertical deflection checks for gravity loads are sufficient. And of course, other checks, assuming all the sway criteria and all other lateral deflection checks are satisfied, then this arrangement is acceptable. Okay. What else? Mr. Harpreet is adding one more thing. If you could answer how to approach design consultancy firms. How to approach design consultancies, as most of them require 1 to 2 years experience, even for entry level. No, so maybe you can start with some person who you know, or some colleague of yours, or somebody who is working already at some consultancy firm. and then approach them. And as I told you, because you have a good experience in teaching, you already have a certain level of experience, so you won't be treated as a fresher. Understood? Because you have almost got what, 6 years of teaching experience, so you're not a fresher in any sense that way. So you're already an experienced person. You just need to get, let's say, apply whatever you already know, and it would be easy for you. It's not very tough. So your case is not like someone who has just graduated or done his or her post graduation. Your case is that you already have a good solid 5 6 years of experience with you. Okay. Yes. So these were the queries for that were put for this session, and I think that's all for this episode. Then, if you, as you all know, you can continue to put your queries in the same Google form. The link for the Google form remains the same, and once every week when we meet, we take up your questions. So this is the link for the Google form that I'm just putting in the live comments. So you can click on this and post your queries. And if you want to, Harpreet is asking which course should I start with from AuxEn. I think you should start with the basic course that we have conducted in RCC design detailing using ETABS and SAFE. So that will be a good starting point for you, where we have covered the RCC design concepts right from the basics, as well as design detailing of each and every RCC element, plus working on ETABS, SAFE, etc. So I think that will be a good starting point for you. And if you want to connect with us on WhatsApp, then this is the link to connect with us on WhatsApp. Yeah, this is the link that I've just put over here. So this is all for this session then. Thank you so much for joining. And uh, yeah, have a good week. We will see you next episode, uh, which we will conduct on next weekend. So till then, have a good week ahead. Thank you very much. Bye bye.